Well, before we got on the podcast today, I was just looking through the news and noticing that an Irish guy had been attacked by a chicken and killed. So you think that the only animals out there that are trying to kill you are polar bears, especially in the wintertime. But I guess we have to watch out for chickens now. Joel, did you see that?
I thought you were going to open up with Mid-American pausing wind turbines because of the Siemens Gamesa blade coming down. But we went to chickens in Ireland. Was it on a wind farm or something, or why is
it? Well, it was near a wind farm, but the thing was that this chicken attacked his legs and like pierced his arteries, and he bled out. So I'm like seriously thinking about going to Chick-fil-A tonight just for a little bit of payback.
and making sure that your life insurance policy is up to date.
Yeah, right. I mean, there's only so many animals you can deal with at one time, and I'm not a big fan of chickens, as our producer will tell you. Chickens are not my favorite animal of the animal world. So now I'm on red alert today. I don't know why that still sticks in my head because there's a lot of wind news this week, and I was going through it the last couple of days, like, oh, there's some really good stuff to talk about, and then this Irish guy and the chicken pops up. So we'll see how this podcast turns out, because we're going to have Phil Totaro on, and Phil's here right now. Phil, you want to describe what you talk about this week?
Thanks, Alan. It's probably not as interesting as chickens, but it's an opportunity for insurance companies, though. So, hi, I'm Phil Totaro. We're here to talk about independent service providers and the cost effectiveness of their maintenance regime on total revenue output for asset owners.
Cool. And after we talk with Phil, we're going to jump over to the UK to some of our Greek friends, Kostas Dimitris and Derek Rutherford over at Perceptual Robotics, talk about what their drone solution is doing and kind of how it looks like to advance in the market and their big contract they hit with NL. And then we're going to go from the sky to the subsea. So we're going to talk about ThayerMahan inspecting some subsea cables with synthetic aperture sonar and AI. They've done a really cool launch and test study off of the East Coast in the U.S., and we look to be ready for the wind farms to get installed for inspections.
And we're going to talk about de-icing wind turbine blades, my favorite topic, and about options that there are for retrofitting wind turbines that were installed without de-icing but turned out to need it, and specifically about Canadian company Borealis and how they're tackling that issue. And I promise that there won't be any more talk about chickens in the rest of the episode. So if you were just about to skip to the next episode in your queue because you're not that interested in chickens, there's no need to worry.
And our wind farm of the week is Longroad's Milford 1 and 2 wind farms out in Utah. They've been working with WindESCo, and it has some really good results from that system. So they're our wind farm of the week. I'm Alan Hall, president of WeatherGuard Lightning Tech, and I'm here with my good friend from Wind Power Lab, Joel Saxum, and Intelstor's Phil Totaro, and the soon-to-be guest of the Fully Charged live event in Australia, Rosemary Barnes. And this is the Uptime Wind Energy Podcast. We have Phil Totaro back from Intelstor, and Phil had some really good data on the influence of independent service providers on maintenance contracts and how that can affect the bottom line. And Phil, you've been looking at this data for a while, and I know all your people are back behind the scenes churning and cranking on the data that you have. Can you give us just sort of a highlight of what you're finding in regards to the ISPs?
Yeah, thanks, Alan. So it's been about 6 or 7 months that we've been kind of digging through all this. And what we actually are in the process of releasing now in terms of an update is some analysis on asset profitability and digging into the influence of maintenance type. So are asset owners who self-perform actually getting the most out of their assets? Are asset owners who rely on an OEM doing better? Or are asset owners that utilize an ISP doing better? So with that in mind, we kind of dug into the data that the Energy Information Administration publishes on plant level production. And we've combined that now with analysis from FERC's publication of a lot of the utility power purchase contracts. And what we're seeing is that for asset owners who have utilized an independent service provider, the total revenue that they generate per installed megawatt is actually higher. So it's about, the entire market average is about 1.6 million per megawatt in total revenue, regardless of asset age, etc. The entire market average is 1.6 million. But for the assets that are ISP maintained, they're actually seeing the lowest is about 2 million per installed megawatt and goes all the way up to about 2.6 million per installed megawatt in total revenue. So the one question that kind of comes out of this is, well, maybe 2 points. One is the insurance companies and financiers involved in this industry seem to have this perception like the OEM is the way to go with a maintenance contract because you're going to get the best bang for your buck. But the data doesn't necessarily prove that out, particularly when you kind of standardize or normalize, I should say, for asset age and for what's kind of been the recent trend in power purchase contract prices, which is to say they've come down quite a bit. Normally, ISPs maintain older assets. OEMs are more prevalent on younger assets, but it's the older assets that are actually outperforming the younger ones at this point.
Well, how does that even happen? If you're assuming you have an OEM and an ISP and they're doing the same level of maintenance, you're getting a drastically different result at the end. Is it just because the ISPs are using the better WD-40 and greases in the turbine, or what? It's a basic repair, right? Unless they've got some magic sauce, which they may.
It's funny when ISPs actually have access. So this is going to get into a whole discussion, I guess, on right to repair and data rights and access to information, etc. I think what's happening is the OEMs might not actually be performing the maintenance according to their own specification. They are desperately trying to claw back lost margin on their turbine sales. And so there have been some younger projects that have had a lot of teething issues. You've also got a lot of these younger projects that have significantly lower PPAs. And like I just mentioned, I mean, we've tried to normalize our data to take those, cheaper PPAs into account. But at the end of the day, if you've got a cheaper PPA, you need to maximize the amount of performance that your asset can achieve. Otherwise, you're seeing a substantially longer payback period on your asset, regardless of whether or not it's generating cash and making money. Your net positive return on capital is 3 or 4 times longer than what it used to be with a young asset in a below $20 a megawatt hour PPA. So there's still some digging that I think we have to do to really try to understand why. That said, I think the ISPs are the ones that have a vested interest in ensuring that they can get older assets to produce, because with a higher PPA price, the asset owner who potentially doesn't want to repower their asset until after their PPA expires wants to see a maximum amount of revenue and a maximum amount of output. So the routine maintenance that the ISP will apply is probably benefiting these older assets and maintaining those assets in their level of performance versus some of the teething issues that have been seen with younger projects.
This spans a couple of things, but I'm asking about in your analysis, have you guys taken into consideration some of the geography, because right now we're just talking about the United States market, right? So when I say geography in the United States market, I'm thinking, okay, in California was really where wind started in the US. I mean, at a larger scale, right? Like they were the first ones to put in big wind farms. So a lot of those older assets are in California that are continuously running. Some of them, they've been cruising out there for 30 years, and that's fantastic. So they've been maintained well, and they're still producing power. But the other side of it is in California, also the labor laws have created much higher rates to be on site. Whereas you might be able to put someone out on site for $30 an hour in Iowa, you're going to pay that same person $40 an hour in California. So that might shift the levels of basically dollars per megawatt, depending on what labor market you're in. But the other side of it too was, when we talk about these older assets still operating, I think some of those are in more favorable wind conditions to operate better. And I don't know, maybe I'm not saying that correctly, but I know a lot of the ones in California, I'm just thinking like, there's like Zond Z50s and stuff out there that have been churning out power since the 90s, and they don't require that much maintenance compared to some of these newer turbines. They don't have as much O&M costs, right? You don't have the tip speeds. You don't have all kinds of LEP issues. So maybe that some of that factors into your calculations as well.
Yeah, it's a great point. We haven't dug into some of those issues yet, but that bears more investigation.
Yeah, maybe it's too granular, right? You guys are doing so much analysis down to the wind turbine level across the entire United States. When you start talking about individual labor laws in different counties and states, that might be just a little bit much. You might have to grow your team a little bit more before we get into that, but just a thought.
So the work that I do in my consulting business is nearly exclusively with OEMs with service agreements, which is really different to when I used to work in Europe and North America, where I think it's not as prevalent. And what I am anecdotally seeing is a lack of motivation. That's in my, my gut feeling is that that's the reason for a lot of the problems, is that there is no incentive for the manufacturers to really be proactive with things. They get things finished, they do their repairs to the sufficient standard eventually, after a lot of arm twisting, and by the time I get involved, it's because the process hasn't gone smoothly. And I know that there's a lot of different levels of OEM service agreement, right? Like some of them are just really basic. If it's we'll do the scheduled maintenance. Then, a little bit more, they might, be a bit more proactive about when they do that maintenance. And then right up at the top level, you see some sort of upside sharing, so that there is an incentive to, do more than the bare minimum to make sure that you're doing maintenance in low wind speed periods, or, when energy is cheap. And probably, some incentive to do predictive maintenance or something like that. And I was wondering if you've separated out those different service agreements, or if there's anything in the data that would confirm my gut feeling about why this is happening. Because, I contrast it with the owner operators or ISPs that I worked with in a lot in Quebec. Actually, there's some good ones in Quebec, and in other parts of the world. And they're really going after it, They want to try something different to maybe get an extra 0.5% AEP. They're not just like, we've got to locate a new blade somewhere in the world. We'll get back to you in 2 years when we've found it. It's totally different level of proactivity, we'll call it. Does the data confirm that, or am I just, is that just my biased impression from my small number of sample points?
No, it's a great point, Rosemary. So what we can probably say at this point, we haven't picked apart every single type of service contract. All we sometimes have visibility to is whether it's an OEM contract versus asset owner self-performing their maintenance. But for the ones where we do have that, keep in mind, even Vestas, when they do an AOM 4000 or AOM 5000 service agreement, you're still getting like basically standard maintenance, but you're also getting the warranty. And like, so your standard maintenance contract might cost you, for instance, like 30,000 US per turbine per year. But your AOM 5000 might cost you like 45,000 or close to 50,000 per turbine per year, because they're including the warranty cost in, on top of a standard maintenance contract. So it's funny because, it's not like if you sign one of these maintenance OEM maintenance contracts with an extended warranty on certain components, you're not getting any better standard maintenance. Like, you're not getting like some higher quality magic, lubricant that goes into the gearbox that does special things that they wouldn't otherwise do. So it's just a question of, are they actually doing the routine maintenance in accordance with the manufacturer spec, or are they trying to cut down on cost, like you said, and maybe holding back on performing some of the even the standard maintenance, particularly if the data that the OEM might have would indicate that, maybe that specification we wrote that said you have to, update the lubricant on the yaw bearing every year. Well, maybe it doesn't have to be every year, or every 6 months. Maybe you do it every year, or every 18 months, or something like that. So
to add to that, Philip, what we were talking about, and I'm not trying to paint anybody in a bad light. This could be an ISP, this could be anybody. But say you have a warranty, and this is just a particular example I'm thinking about, right? Say if you're on the hook for the warranty, right? You're at a whatever level of service agreement where you are now on the hook for the warranty, and in the neighboring wind farm, you're not. And if you look at two of the same turbines, and one of them, or they both have the same kind of, like, say something like there's a pitch bearing that's kind of going bad, on one of them that you're on the hook for the warranty, I would say before it actually fails, you have more of an incentive as that contract holder to say, like, hey guys, we know this one's probably going to be bad. Let's get one on order. We're gonna replace it when we have a low wind day or whatever that part may be, because we know it's kind of going bad. Whereas on the other one, you're gonna be like, as soon as it goes down, they got to pay us. So maybe we'll just wait. Does that make sense?
that might be part of the answer, Joel. That does make sense, and I don't have, there's not enough publicly available data to be able to confirm it, but I think based on what we all know about how the market works, I think that is a logical assumption.
Nobody's putting that on the internet.
What I think this does is it brings up the question, like Rosemary mentioned, do we need to continue doing contracts, service contracts, per turbine per year with, annual escalators and availability guarantees and all that? Or does this necessitate the need for the industry to shift more towards, a maintenance contract per megawatt hour that they're producing, and performance bonuses may be, and like a revenue share may be included? I think that's something that I think needs to be talked about a bit more, potentially in relation to this very interesting outcome.
Well, if you're an independent service provider and you've just listened to this discussion, you need to get a hold of the Intelstor data, because that data is extremely valuable to you as you're approaching operators this season. And the way to do that is to go to intelstor.com or connect with Phil Totaro on LinkedIn. Phil, hey, thanks a bunch for being back on again. This is really great data.
Get the latest on wind industry news, business, and technology sent straight to you every week. Sign up for the Uptime Tech newsletter at weatherguardwind.com/news.
Perceptual Robotics, which is a Greek drone company, is ready to enter the U.S. market, and they have some backing by Brook Street Equity Partners in London, and they're looking to make a big push into the U.S. in the first quarter of this year. So Perceptual Robotics actually comes out of Bristol, UK, and they're pushing their autonomous drones and advanced robotics. They have a lot of backing. They have previous investments from international investors, TSP Ventures, Future Fund, Humble Holdings, and Metavalent VC. So it's a relatively new company too. It was really started in roughly 2019, and they're off to the races. So Joel, I know we have talked about this off air. There's a number of drone companies in the marketplace right now, particularly in the United States. And having Perceptual Robotics join that list, it sounds like a pretty heavy load to take on. The U.S. is a difficult marketplace.
Yeah, I think that they did something smart. So I've talked with the team over there, Demetris and Costas at the beginning, and then Derek Rutherford does a lot of their BD and stuff for them. Great group of guys, very intelligent. They've got a good product going there. What I've seen from their AI actually is it's very good, which I don't say a whole lot of blade inspection AIs. But what they did, I was talking to them last fall, and I thought it was very smart. And we were talking with Wind Power Lab and those guys about doing some tests and some things. We looked at some of their data, and what they said, right now we just want to hold up. We plan on doing about 500 to 1,000 inspections in Europe, and we don't want to go anywhere else besides there for this year. And I thought to myself, like, oh, why wouldn't you take the opportunity to come over to the States? And I was like, you know what though, that's pretty smart. Just kind of fine tune your craft before you decide to take it, into 8 time zones away and send people out into the field. So I know they have signed a big deal with NL. So if they've got NL on the books, that may be their vehicle to come to the States. NL, of course.
Well, are they even drone companies today? Or are they just software companies?
Yeah, that's a good point, Alan, because I think that Perceptual Robotics uses the DJI M300 as their platform. So they have a little hardware package, or not little maybe, but a hardware package that goes on it that has the camera and probably LiDAR and some other things that most all of them have to localize themselves and maintain distance. But then it's software, right? I know one of the companies I talked to a year or so ago, in their autonomous navigation software, there was over 150,000 lines of code. So you've got to be a pretty developed software company to be able to maintain something like that in an autonomous flight situation.
Right. North Labs is doing something similar. So if it is moving to a software world, eventually they're just going to have to get out of the hardware business. The hardware business is going in a completely different way, and it's expensive business to be in. Does that then drive the marketplace in terms of the drone companies are now software companies, and instead of offering a technician and a drone and to pilot the drone, is it just then you're going to rent the drone from a SkySpecs or a drone base type company and it'll do its thing, and you don't even you're not involved with it. You know what I mean?
If I'm the asset owner or the O&M contract holder, that's what I would want, because I would want to be inspecting, be like, there's a downwind day, like, hey guys, go grab the drone and do some inspections, instead of having to have a guy on site. He's going to be here for these 2 weeks. We've got to cater to that contractor the whole time. Make sure make sure we've got the turbine shut down, and this one's shutting down as this one's moving. And if we have to pay for, if the weather moves in, all of a sudden we're paying $90 an hour or whatever weather time for this guy. If I could avoid that, I would. And then it comes down to the data, right? So
does it though?
Well, when you introduce these little tiny drones, they don't get as good a data with the camera, right? So, and I know, okay, so from the Wind Power Lab side of things, we vet people very hard on their image data quality. Because if you don't have good image data quality, your AI just won't work. Or if you have a blade engineer or some other engineer looking at the inspections, it's hard to tell, right? Like, that's why people have got away from the robotic camera on the ground, because you can only get like 2 millimeter per pixel resolution out of it. That's no good when you're looking for hairline cracks.
Well, it's just a matter of time though, right? You give it another year and the camera is just going to get better and better, and the drones are going to get smaller and smaller, or more accurate, be able to fly closer.
Yeah, that's the tough thing right now, right? Because you could just get closer. That's the solution. But a wind gust comes along, and not a lot of these drones can correct themselves that quickly.
So it is a very, I think, a very difficult marketplace at the moment to be in the United States. There's so many big players who have, like a SkySpecs, who has a tremendous amount of funding to fight off new entries into the marketplace, which is what will happen for sure. So Perceptual Robotics will have a very interesting spring and summer in the United States. We just have to keep an eye on it because the marketplace is changing rapidly there. Joel, on the East Coast, there's been a number of projects wrapped around subsea cables. And what are you going to do with these subsea cables once they're laying on the seafloor? You're going to need to inspect them, particularly if you have an idea that something is wrong. How are you going to find out where the damage is? Those cables are miles and miles and miles long. So the Connecticut-based ThayerMayan has been working with their underwater scanner called Sea Scout. And they did a little bit of an experiment back at the end of 2021 with a grant from the New York State Energy Research and Development Authority and the National Offshore Wind Research and Development Consortium, where they took their Sea Scout drone behind a ship and they put some damaged cables on the seafloor and used that Sea Scout system to determine if they could see or image the damaged cable accurately. So it's a real world experiment, not something done in the lab, not something theoretical. They actually went out and did it. And the images that I've seen, and there was just, they had a presentation at Northeastern University a couple of months ago. The images were amazing. That Sea Scout system can image the seafloor extremely well. So they're thinking that this may be a way to really detect cable damage as the cables are being laid. And if there's something were to happen later on in service, they could relatively quickly identify it and get it fixed. And Joel, you know a lot about this underwater scanning technology. You want to describe what the Sea Scout is and what ThayerMayan is up to?
Yeah, so at the basics of it, you got to understand that while the general population doesn't see this, there are thousands of miles of pipelines and thousands of miles of data cables and power cables and all these kind of stuff on the subsea, right? On the seafloor. So if you go into the Gulf of Mexico and if you start Googling some stuff about like where's oil infrastructure in the Gulf of Mexico, just right off of our coast in the US that you probably have never seen before, there is miles of pipelines everywhere. I mean, it's like someone threw spaghetti noodles out there that are 100 miles long. So in pipelines and export cables, power cables, data cables have been out on the seafloor for, since the 1940s. Or 1930s. They've been there for a long time, and there's a lot of them. So they've been inspected in a multitude of different ways forever. Now, a lot of that used to be, and there's still contracts that go on like this, where literally there's one guy flying an ROV. An ROV is a remotely operated vehicle. It's basically like some of them are about the size of, I don't know, a small car, like a Mini Cooper. A lot of them are about that big. And they have a guy or a gal sitting there driving the thing, and then another person sitting with like 5 screens in front of them, staring at those screens for 10 and 12 hours straight. Just like this, if you can see me on YouTube. and that's all they do, right? So they're just looking at it going like, and it's a visual inspection of this pipeline. So they're looking for certain things like anode depletion, right? So you have to have anodes on the pipelines so they don't interact with the seawater and cause corrosion. So they're looking for anode depletion. They're looking for, if they had a rock dump on the pipeline to keep it in place when they built it, is the rock dump still stable, right? Or has there been scour under the pipeline or under the pipeline or power line so that there's a gap there now, and now that pipeline is sagging or power line is sagging. If you do that, you start to stretch the cable, right? So they're looking for these things on basically live video feeds, and it takes forever. It's super inefficient, and you have teams of people out there reviewing video for hours and hours and hours on it. The other side of that is it's a human eye. They're going to miss stuff. It happens all the time. Right? There's no way that you're going to expect someone to sit out there for a 4-week shift and stare at screens and catch every little issue that they find. So AI has come along in the last few years. Almost every operator of ROVs, digital video recording systems, anything that works offshore or subsea, has some kind of AI either on their platform or in the works in the background that they're utilizing to help alleviate the stress on the human and the human error. Cruise along that pipeline, and all of a sudden AI is picking up anodes, and it's picking up free span, and it's picking up dents. If it sees any kind of ovality in the pipeline that's off, like it got squished, it will pick that up. So that's great, but you're still looking at video. Now some of the newest solutions are, well, we can also take that AI and feed it back into the control systems of the ROV and have it fly itself. So now they're taking vehicles and just throwing them in the water, getting them to the pipeline and saying like, all right, we'll pick you up in 1,000 miles when you reach shore. And that vehicle will just cruise along that pipeline the whole time, localizing itself by basically slam navigation autonomously, and then pop up and say, here's all your data. Problem there, okay? Now you're running across, say you're in the Red Sea and you run across a shipping lane, and there's been a ship that went by, and now the ship has stirred up the bottom. You can't see anything. Visually, you're up a creek. You got no more navigation. What happens then is that little autonomous vehicle will pop up to the surface and then try to ping itself or let you know, hey, back at control center, like we got a problem here, blah, blah, blah. That's where you have sonar come in. So sonar operates, and you can get high resolution sonar as well. It's not like your fishing boat sonar. These things are $250,000 a piece. And so you can get a couple fishing boats for that, at least inland fishing boats. But so now you have that resolution, but that resolution from those is good. It's good enough to see, infrastructure on the bottom. It's good enough to know there's a pipeline there and to maybe see some free span. If you get real close to it down in 10 meters or so, you can see some detail, but you're still looking at a ground if you're flying 10 meters above it or 5 meters above it, you're still looking at a ground sampling distance of a centimeter, 2 centimeters sometimes, depending on what kind of data you want to have. So the next step in all of this is synthetic aperture sonar, which is what ThayerMahan is using in this project. So synthetic aperture sonar it's not a new technology. It's been used by the military for a long time. They use synthetic aperture sonar to see through clouds and stuff for military operations in the sky. You can also, there's some really cool research to actually find subsurface assets on land with it, like to look for pipelines by flying a drone over the top of them. But that's not what we're talking about here. And so what they're doing with synthetic aperture sonar here is it turns basically like what would be a 480p picture, and I'm just trying to kind of make it seem a little bit easier, a 480p picture into what would be like an 8K image. Right, that's the kind of difference. Right now we're talking imagery. This is point data, right? It's bounce back point data. It's backscatter. So it's still sonar beams pushing, bouncing out and giving you data back. But now that you've got such high resolution, you can start to apply AI algorithms to that vector data, that point data as well. So they're really they've gone from looking at it visually to looking at it with AI to navigating along it with AI to switching to sonar and now switching to synthetic aperture sonar and now using AI with synthetic aperture sonar. And it's the next level, right? This is it's super cool to see them doing this, because if you followed anything offshore wind, you know that there's $1 billion loss in the North Sea right now with export cables, right? And if they were able to efficiently and accurately inspect those things regularly, the North Sea has 1 to 3 knot currents on the seafloor 24/7. So that creates scour, that creates movement, that creates a dynamic environment where you just think, oh, it's the seafloor, like it's in the water in the bottom of my glass. No, that water's always moving. So when the water's always moving, it creates a lot of, the silt and the sand moves, and the export cables can be moving around. And if the rock dumps missed them on their initial dump, then that export cable can just kind of like move along the subsurface. So if they can do it more efficiently, more accurately, and with AI where they're cutting some of the human error out, it's a win all around for the offshore wind in the US and globally.
I assume it can detect things like gas line breaks, like Nord Stream, those kind of things, right? I mean, that's the technology you could use it for. Does that mean that they would have to be continually out in the water monitoring for the movement of cables, particularly in places that they haven't been before?
Well, with the new technology with AI and SLAM navigation, you can launch this. You can launch an AUV quayside, at the port, and then send it out. And then it can surface when it gets out to the wind farm after it's inspected that whole length of cables, download the data back to shore, and you can give it a new mission. Okay, go down again, and I want you to follow these cables out to the interconnects within the farm, inspect all of those. You could have a resident robot out there running. There's a company in Canada right now that's making a robot that the fuel cell is hydrogen, and they're going 4,000 kilometers on one charge.
Well, Rosemary loves hydrogen, so there you go. 2 problems solved.
Yeah. If you can do 4,000 kilometers of, you can inspect, all the wind farms in the New York Bight in one go with that thing.
Is that the next move for SkySpecs, is to move into the underwater drone market?
I don't know. Unless they hire some new people, there's a lot of people in that space. That's a very niche industry with a lot of knowledge, and it'd be tough to just move into it.
Yeah, it does seem like a difficult problem to solve, and it's one of the few research things that I've seen that has direct application to offshore wind in the United States. They can use that tomorrow, even with Block Island. They have some images of the Block Island wind farm, which were really interesting to see on the website. So check out ThayerMayan website. You can see some of these images. They're really impressive. Joel, and thanks for that update, because the technology is beyond me at this point, but that was a really good summary of it.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS, so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
Borealis Wind, which is a company based in Waterloo, Ontario, Canada, has a blade de-icing system. And of course, because Canada is so dang cold, they need blade de-icing systems up there. And it has, for me, a little bit of a unique twist. It has a heater and a blower in the base of each blade, which I guess makes sense, right? But then they have like an inflatable tube that runs along the leading edge of the blade in like a piccolo tube situation, which is something we would use on aircraft to heat the leading edges of a wing to get the pressure and the heat distributed more evenly. That's what it looked like to me on the videos I've seen. And I want to talk to Rosemary about it because she's our resident blade de-icing, anti-icing expert. Rosemary, have you seen this system up close or maybe from afar? And what are your general thoughts on something, basically an anti-icing upgrade or mod?
So you said a piccolo tube. Does that mean like the instrument of piccolo, it's a tube with holes in it?
Yes, it's a reference to the instrument.
Okay. I'm not sure if it does have holes.
Oh, really? Is it just dumping heat out?
I mean, they don't have heaps and heaps of information on their website, but I feel like it's just a duct that they roll out. It must taper, otherwise you'd have to have either a very small tube the whole way through, which would have a lot of pressure loss, or it wouldn't be able to go very far. Yeah, so I mean, to answer your question, yes, I've seen this. I'm pretty sure I was aware of it when they were started in about 2016, 2017 or something. So that's when I was, heavily day-to-day focused on de-icing all day long. So this company, it's one of only a couple of methods that you can use to retrofit an existing wind turbine with a de-icing system. And that's especially important in Canada. They were some of the first to put wind turbines in icing areas, and some of those early wind farms did not realize how much of a problem that icing was going to be. So you see some wind farm owners that are suddenly faced with 10, 15, even 20% or more AEP loss from icing. And, obviously that's like absolutely devastating. You don't normally deal in tens of a percent of losses in the wind industry. So they're scrambling to find just absolutely anything that they can to claw back some of that. So the Borealis system, it's a hot air-based system. They put a giant hairdryer effectively in the root of the blade, and then they roll a duct out through the leading edge. They blow hot air through the leading edge of the blade, and then it probably just comes back through the blade wherever it can. The air comes back. So it's not super controlled. There are some manufacturers who make a de-icing system for their blades that also use hot air. LM or GE have one or had one. I'm actually not sure if they're still using it because they've got another one as well now. And then Vestas also had one, kind of tried to change, maybe changed back or moved to a hybrid system. Again, I'm not 100% sure where they've ended up. Enercon as well. That's another company that used hot air. And then the other alternative is a resistive heater. So usually that's done by you lay carbon fiber over the leading edge and then you apply a current to the carbon fiber because it conducts but with some resistance, and so it heats up just, like any kind of electric heating element. And that's much more targeted because you can imagine if you put the heating element right on the blade surface where the ice is, then it's very, relatively easier to melt the ice off compared to the hot air systems, which require you to heat up a lot of the blade that doesn't have ice on it. So you need heaps and heaps and heaps of power for a hot air system. That's its first drawback. And we're talking as much power. If you wanted to keep the whole blade ice free, you'd need as much power as the whole wind turbine was producing. So yeah, it's not feasible to, take ice off the whole blade in all conditions. A hot air system or any system is only going to work in a certain subset of conditions. And for hot air, it's going to be at relatively mild temperatures and over a relatively small area of the blade. Yeah, and then there's some other disadvantages with the hot air systems in terms of all the components that you've got in there. You've got heaps of moving stuff. So first of all, you've got the fan that you've got to put near the root. You can buy a fan off the shelf that has been tested, for, hundreds of thousands of operational hours, but the fans were not developed to go up in a wind turbine, which is, got a lot of vibrations. It's also rotating. The fan's also rotating. So you've got to be careful about how you align axes. Otherwise, you can end up with the whole thing shaking itself apart quite quickly.
From gyroscopic effects?
Yeah, and there was one of the manufacturers who had one of the earliest de-icing systems did shake apart a whole fleet of fans in their de-icing system when they put them up. But it happened very quickly, so they soon realised their mistake and got back to fixing it. And hopefully it wasn't a huge amount because it was first trials. So I assume they wouldn't have gone too big. But yeah, that can happen. Yeah, other disadvantages, the other big disadvantages is the duct, the flexible duct. Wind turbine blade is a really high strain operating environment. They bend a lot. So you've got all these bends constantly happening. You put a flexible duct inside of blade, and you can imagine every time the blade flexes, then this duct is going to rub a bit on the side. And, it's going to happen thousands, hundreds of thousands, millions of times eventually. And my personal experience was that these surprise you how quickly they can wear out. I remember one test that I did in the lab showed, okay, this will last the full lifetime of the wind turbine blade, safety factor of like 10 or 50 times. It was huge. It was like, yeah, this is fine. This will never replace. I went up there, climbed up there 3 months after they were installed, and it looked like wolverines had been let loose in there. Everything was just shredded. It was incredible how little my lab test had to do with the reality of what these blades looked like. So we had to change that design quick smart, obviously, because you can't be going up there every couple of months to replace ducts. I don't know what materials that they're using, but flexible stuff in wind turbine blades sucks. You can kind of probably get some sort of intuitive understanding by thinking of things that flexible things that move a lot. So if you think about like a sail on a boat or a flag, those things get tatty, right? Especially a flag, they get tatty quite quickly. That's the kinds of operating environment that you've created for this flexible duct. So I think in general, it's a good principle for anything you're putting in a wind turbine blade to not have anything flexible. It's challenging. All of my biggest component headaches that weren't related to lightning were related to flexible components, of one kind or another. So yeah, that's two problems that the Borealis system's going to have. I haven't seen a lot of information about how they're actually going in the field. They do have systems out in the field. They have referenced journal paper on their website that kind of makes it sound like it's sort of validated their performance, but it hasn't actually. If you read it, it's saying that that's not what this is trying to do. We're looking at trying to figure out what's the right method that we would use if we were going to validate. So that's a bit different. So so I guess I should say I have no real experience with the design and the materials that they're using. So I couldn't comment, but based on my experience with making very similar systems work, I'd be really surprised if this was an effective or durable solution. I bet that you have to replace those ducts annually would be my expectation, or bring them in at the end of the season. I don't know. It's probably got a pretty narrow band of operating temperatures. I'd be surprised if you could use it much below, say, -5 degrees or something like that. But then again, that does capture like a really large amount of icing. Icing events usually get worse icing around 0 than you do at colder temperatures. But the fact of the matter is that if you have installed a wind farm and you have icing that you weren't expecting, you don't have the option of saying, okay, well, I'll go back in my time machine and say I would like the icing package on my wind turbine, please. You've got few options. You've got this one from Borealis, and then you've got WindESCo is the other company I think has been on the show before my time. They're the other company. It's only those two, as far as I know, that are offering retrofittable de-icing solutions, and they have one of those conductive systems like I was mentioning. And it's a huge, huge process. You have to take all the blades down, build a portable factory where you can do, like precision carbon fiber lamination, because you can't get wrinkles and stuff in these elements, or you're going to create hotspots. And the stakes are higher with a carbon fiber thermoelectric system, because you can set blades on fire that way. So the WindESCo system, I think you're more likely to end up with something that's really effectively going to remove ice in at least moderate to challenging conditions. But gee, it must cost so much to do that. And of course, if you're looking at a 20% AEP loss every year, then you've got a lot of money that you're probably happy to spend to reduce that. So I can see why, the Borealis system, whilst it might not be, it's certainly not going to work as well as something you would buy from the manufacturer right from the start. But I can see why it would be appealing to, if you don't have that bad severe conditions, I can see why you would try it. I bet it costs not that much. One question, though, that I do have is how, because, in the blades that I've worked in, of several manufacturers, the leading edge cavity where they're putting these ducts, it's not just an empty space. There's usually bulkheads in there, blocking it off every, 10 meters or so. And I want to know if do they get in and get a big Dremel, grind them out? They do perform some sort of a structural function. It's not primarily structural. It's mostly to help in, manufacturing and stuff. But I always wondered how they actually managed to fit these things in there.
Well, it probably depends on the specific blade type. That I think the blades I've seen, they're mostly open on the leading edge until you get closer to the tip. And
fully all the way down, though?
A good bit of it, sure.
The OEMs that offer this as like an OEM installed option for a new turbine will lay a conduit in the leading edge, having precision carved out a piece of the rib, each one of the ribs, if there are those kind of vertical stays.
Yeah, but sure, they've redesigned their blades so that it can fit. Whereas this company's going to be dealing with blades that were never intended to have this system. That's their problem. And the tip is exactly where you need the air to flow. So, I'm just, it would be interesting to take a look at a blade that, that's had this put in and see how that works.
Well, I guess this speaks to how difficult it is to get into the wind turbine market. That was my comment to Joel about this, or maybe to everybody on Slack the other day, was they've been working on this project for about 6 years, maybe 7 at this point. It is really hard to get a product onto a wind turbine. It is immensely difficult just because of all the variables that Rosemary, you just mentioned. There's a lot of things you don't know until you get into service. And even if you're working for the OEM, you don't have all the data in front of you. Some part of it is just real world experience. You're not going to know until you do it. And then once it always goes sideways, it has to. That's the way engineering is, and it's how fast you can recover. And is the idea still good enough to pursue?
You need a wind farm operator who is absolutely desperate because they're losing so much money. And there are plenty of those in Quebec, plenty of operators that are pretty desperate, because it's not only, the very first ones that happened before they realized icing was a thing. There's another problem where, people get icing assessments done and they need the icing assessment to say that there's not going to be a problem with icing, because that massively affects the financials of the project, and then, going to be much less likely to be able to get it financed. So the people that do the icing assessments are, in my experience, anecdotally, they're routinely underestimating the icing. And so, back when I was working on this, I would say to people, below 5% annual energy production loss from icing, I would not bother with a system. You'd be better off just turning it off. Turning it off. Well, you can operate through a fair bit of icing and then turning it off for bad icing. Above 5%, then you really want to have a proper system. So, if you get a report back that's like 4%, but it turned out actually it was 10% losses, like I said, it's too late. You can't go back in time and change your mind, and the retrofit options are just not good.
That's why you need someone like Joel to step in, because he's from Wisconsin. 9 months out of the year, there's ice. You need someone who lives up north to tell you it's icy up here.
Well, I'm looking on their website right now, the Borealis guys, and hats off to them for keeping at it for so long. Like they believe in their solution. So I'm looking at their map and it says Ontario and a couple of spots in Quebec. Icing there for sure. Rosemary, you've spent some time up there as well. But there's a lot of places in the on the North American continent where there is icing problems just like this. You can stay in Canada if you want. You can go all the way across Alberta, Saskatchewan, over to Calgary, into BC. There's wind farms out there that ice all the time. But my advice or thoughts would be go to Winter Wind in Sweden. Would be the first one. Talk to all the asset owners over there. The other stuff would be look into, hey, you see an icing event come across the news, call all those wind farms that could have possibly been affected by that, because someone that is immediately feeling the pain is more apt to pick up the phone to fix their problem. So like this right now, today, I talked to one of my colleagues who's in, where is he at? Brookings, South Dakota. He just drove from Minneapolis in a snowstorm and an ice storm all the way out there for 4 hours. I would call anybody in that corridor I could and get on the phone and just be like, hey, I know you guys are experiencing icing right now. Do you want this to not happen to you? Let's have a conversation. Because then you can get into the technical details, right? Like Rosemary is saying, if the design of the blade itself stops you, like if it's a carbon spar blade, what are you going to do, right? Like the carbon spar, there's no opportunity for return air. So it's only going to work on certain blade designs, but at the more you get into the market, the more you understand exactly what those ones are. Chase those people that have the good blade designs that it works on.
And Wind Power Lab's going to be at Winter Wind, right, Joel? And WeatherGuard Lightning Tech's going to be there also, up in Sweden. So if Borealis shows up, we'll be there. We can meet up in Sweden.
Yeah, absolutely. Or at O&M down in, I think you guys are going to O&M, aren't you?
Yeah, we're going to ACP O&M in a couple of weeks in Orlando. It's not really an icy place, unlike Winter Wind. Our wind farm of the week is Longroad's Milford 1 and 2 farms in Utah. And there's actually, so the 2 farms were built in like 2009, 2011. There's 165 turbines. So it's 306 megawatts total, with a mix of Clipper 2.5 megawatt machines and GE 1.5 megawatt machines. Longroad is based in Boston, and they've been working with another Boston area company, WindESCo. And WindESCo installed their swarm system on the Milford site. They first began by instrumenting 10 different turbines, and the swarm system adjusts the yaw of the wind turbines to avoid wake losses. So it's a pretty smart system. They began with 10 turbines instrumented, and then at the end of 2022, they actually instrumented the whole farm. 165 turbines now have swarm, and they're going to be commissioning that in early 2023. So good news from WindESCo, good news for Longroad at the Milford wind farms, and because they're predicting AEP improvements of somewhere between 1 and almost 4%. So that's a lot of power production over time. So congratulations to the Milford 1 and 2 wind farm and Longroad as being our wind farm of the week. That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Please give us a 5-star rating on your podcast platform and subscribe in the show notes below to Uptime Tech News, our weekly newsletter. And check out Rosemary's YouTube channel, Engineering with Rosie. And we'll see you here next week on the Uptime Wind Energy Podcast.